Hi, my name is Blagica Kristeva and I am a software engineer at ModelOp. Today, I will demonstrate the functionalities of our product, ModelOp Center, as it integrates with Spark. We will begin our demo by registering a PySpark model. We will then use the same PySpark model to deploy as batch, run a test job, and run a data drift monitor. Please note that our integration works with Spark and any flavor of Spark, and it is configured to authenticate and run in an OAuth 2 in a Kerberized environment. We will now start by registering a PySpark model. In order to do that, we need to go over to the Models page and click on Import. Then we select Git and provide the Git URL of our PySpark model. We assign a default access group of ModelOp and select HDFS as our storage type because that's where we want the model assets to be stored on import. Finally, we import our model. With our PySpark model now registered with ModelOp Center, if we open the attachments page, we can see the assets added on import, including our primary model source code and our two other Python files. The reason for registering a model with ModelOp Center, which is model agnostic, is to keep track of all models running in production from a governance and auditability perspective. Now, with our PySpark model in our model catalog, we can deploy the model as batch. In order to do that, we need to open our model and click on Create New Snapshot. The snapshot will represent an immutable version of our PySpark model. For this snapshot, we will use the default name. We will tag the snapshot with the Titanic tag so that we can reuse this snapshot later to create a batch job. We want a runtime of type Spark. There will be no associated models for this snapshot. Then we click on Create Snapshot. The final result of this process is a deployed model for production usage. ModelOp Center takes an immutable snapshot of the model for long-term auditability and provides detailed traceability on all of the steps a model took to get into production, which can include model risk reviews, IT governance approvals, rigorous automated testing, etc. For this demo, if I open the MLC that we use to deploy our PySpark model as batch, we have streamlined the deployment for time's sakes, but here is where the model lifecycle is tracked. With the PySpark model deployed as batch, we can now create a test job. Normally, these jobs are run by a scheduler, but for demo purposes, we will run one job manually. And for that, we need to go over to the Jobs page and click on Create Batch Job. The model we want to use is Titanic Spark, and in particular, the snapshot that we just created. The job will run on a Spark cluster managed by our Spark Runtime 1. The job type will be a metrics job. And on this page, in addition to schema checking options, we can also provide any Spark configurations or arguments specific to this job, such as executor memory and number of executor cores. As an example, I will provide a custom value for Spark executor memory. As input asset for the job, I will provide the URL of my input file located in HDFS. And I would like my results to be also stored in HDFS, for which I will provide another URL. Now that we have submitted the job, we should observe changes in the job status from created to waiting to running and then to complete. Once the job starts running on the Spark cluster, ModelOp Center will display the Spark cluster's tracking URL for the job, as well as the Spark application ID. One could click on the tracking URL to access more job-related info such as standard error or standard out, or you can inspect standard error and standard out in the logs window here in ModelOp Center, which will get fully populated once the job completes. And our job did complete successfully, and we have available the tracking URL, the application ID, as well as the Spark cluster logs. ModelOp Center supports multiple types of models as well as multiple types of runtimes, but we still have consistent monitoring. As an example, we will look at data drift monitoring, where we interface with our Spark runtime and the Spark cluster overall to calculate data drift for our PySpark model. First, we will register a new model, which will be our drift detector model, and create a snapshot of it. Second, we need to add an additional attachment to our Titanic Spark model, which will serve as our base model. The new attachment or asset is the training data, which we will upload by URL because the file is already located in HDFS. And because this asset represents our training data, we have to make sure that the asset role is set accordingly. Then we need to create a new snapshot of the model that will encapsulate the newly added asset. For this, I will use a more memorable name. Again, we want a runtime of type Spark. We will have an associated model for this snapshot, and that will be the drift detector model. The association role that we want to use is data drift model. And for assets, we want to provide a comparator data, which is already located in HDFS. So again, I will provide the URL for it. And then we click on Create Snapshot. Now we're ready to trigger the MLC using the base model's snapshot ID, and we will be able to see the execution flow of the MLC in ModelOp Center. As a result of the MLC's execution, we will have a new drift test job, which we can confirm by going over to the jobs page. And our job is in created state. If we go over to dashboard, you will notice that we have process notifications, which are also the result of our MLC's execution. And our drift job has completed successfully. If we go back to our base model, Titanic Spark, and open the snapshot that we used for the drift job, you will notice that ModelOp Center provides a model-centric view of what we have done to the model for purposes of operation improvements as well as governance and auditability. And this model-centric view includes the model test results as well as the MLC used. This concludes our demo on ModelOp Center integration with Spark. Thank you.